Sorry for the delay, everybody. You have a rookie on the technical controls tonight.
Hello, everyone. Welcome to a new Keep Looking Up. Kurt's running our tech tonight, and you did great. It's great. We're really excited to share this show with you tonight. We're going to be talking about how astronomy has influenced pop culture. And it's just going to be a really great discussion tonight with our whole crew and you. So if you have questions about any books or TV shows or movies or anything that you have seen with astronomy in it, feel free to include that in the comments and to add to our discussion. We'd love to hear from you. I'm Tiffany Woolbrick, planetarium lecturer at Ward Beecher Planetarium. We have Kurt Spivey, our tech guru and planetarium engineer. We also have our students. We have Eleni Hunzik.
Hello.
And Nishan Adhikari.
Hello.
And Jenny Phillips.
Hello, everybody.
All right, so we'll start, I think, with the star talk. Take a little look at our current night sky. I think that's a good plan. And please, y'all, if there's any comments in the Facebook chat, let me know. You can interrupt me. I'd love to hear from y'all. But first, I'm going to switch over to a wonderful program. If you've seen any of our shows online, any of our Keep Looking Ups, you know about it already. This is Stellarium. Stellarium is a free open source software that's basically a virtual planetarium. It's really cool. So I highly recommend playing around with it if you're interested. Stellarium here, I have it set for tonight at about 10 o'clock. And we're facing north over Youngstown. Although this isn't super realistic because I turned the atmosphere off, and this is even without light pollution. So in a city, even a small-ish or smaller city like Youngstown, there's still a ton of light pollution so it makes it difficult to see all of these stars. But in Stellarium, I just hit this letter A for atmosphere, and we can see all the stars that are above us, which is really, really neat. We're facing in the north. This is going to be a quick overview for most of you, or for some of you who've seen our shows before. But the north is always a great place to start to orient yourself in the nighttime sky, because the sky in the north doesn't change too terribly much throughout the whole year. Very, very low in our horizon right now at this time of year is our little asterism, the Big Dipper. Okay, it's in the constellation Ursa Major. Okay, you can see our big spoon. You actually can't see the bottom star there. This has a tree. Stellarium is simulating a tree right there. So if you don't have an absolutely clear-cut horizon here in Youngstown, you won't even be able to see that third star right now in the handle of the Big Dipper. And depending on where you live, the Big Dipper could actually disappear for certain parts of the year. And in the southern hemisphere, you can't see it at all. Or you can't see most of the north sky at all. For example, where I grew up in South Mississippi on basically the Gulf of Mexico coastline, that is at latitude 33 degrees. So that means that everything is shifted down to, like, here's these two stars here point you to Polaris, or the North Star. North Star is much lower in my hometown where I grew up. So if you shifted everything down, that means that the Big Dipper actually dips below the horizon this time of year in South Mississippi. So, and other areas of the world. But in Youngstown, we can still see it. We got a nice, great view of it. As long as you don't have a neighbor's house or a tree there, we can still use it to find Polaris, our North Star, which points us exactly north. It's also in the handle of the Little Dipper. which is in the constellation Ursa Minor, the Little Bear. If you don't have a great view of the Big Dipper because of where you live or whatever sky you're using, you can always, where are you? There's Cepheus. I've lost it. Maybe I have too many stars. I do have too many stars. Here we are. Sometimes it's hard to find constellations, especially the bright constellations, when there's too many stars in the sky. It's a good problem to have. But the constellation I was looking for is Cassiopeia. She is on the opposite side of the Ursa Major, the Big Dipper in the sky. So when the Big Dipper's low in our sky, Cassiopeia is very high, and you can also use it, the two brightest stars in Cassiopeia, to draw a line down to get pretty close to the North Star. So Cassiopeia and many of these constellations have been represented in our media and through stories for thousands of years, really. In fact, most of the constellations that we talk about are based out of ancient Greek mythologies and Greek stories. And so these constellations have their characters. They have stories to tell. For those of you who've gone to the planetarium physically, to Ward Beecher Planetarium, you know, around this time of year, around in September, October, we have a Harry Potter show, usually a Wizarding Weekend show, where we talk about how the wizarding world specifically was really influenced by astronomy. So Cassiopeia was actually part of the Black family in Harry Potter. So if you're into Harry Potter and you're into that lore, one of the Black families was named after this constellation. And that's sort of an esoteric character. You don't get to know that character a lot. It's really just more the family. But one character you probably do recognize if you've seen any of the movies or read any of the books is our constellation Draco. Draco the dragon, or Draco the snake, depending on the origin of the myth. It snakes between the two dippers. So there's the head of Draco and then the body. And Draco is a very popular and well-known Slytherin in Harry Potter lore. So I'll be talking a little bit about some of the Harry Potter characters that we can see in the nighttime sky in lieu of our Wizarding Weekend. But there have been many, many books and movies and different things that have focused on different areas of the nighttime sky, or have gained inspiration from the nighttime sky. So a good example of that is this bright star in our northwest called Vega. Vega is in what we call the summer triangle. These three bright stars here. Let me see if I zoom in. There we go. There's Deneb, Altair, Vega. These three bright stars here that form a triangle, they make the summer triangle. I know you're thinking, it's not summertime. Why is it called the summer triangle? Well, it's because this can best be seen during the summer months. If you notice, our summer triangle is very low in our western sky. And just like the sun comes up in the east in the morning and sets in the west at night, that's the same way that the stars move across our sky. So the summer triangle is not going to be up for very long. It'll begin to set around midnight or so tonight. You can actually see the summer triangle in the early evening sky well into December. So maybe not the most apt name, but there you have it. There's a lot of cultural references to stars in the summer triangle. The one I'll focus on today is Vega, the movie from the 90s movie Contact, starring Jodie Foster and based on the book written by Carl Sagan. The signals that they heard from that movie came from Vega. They talk about Vega a lot in the plot of that story. So that's where you would look in your nighttime sky for those if you're thinking about contact and the radio signals that they first heard, or they made first contact. Pretty exciting. I'm going to switch back. Oh, I'm going to just keep moving towards our south sky here. Still 10 o'clock tonight. High in our sky is the planet Mars. Mars reached close approach to Earth. I think it was sometime in September. It's been a couple months now, but it's still fairly bright in our sky. So in Harry Potter, there was as the centaurs say in Harry Potter, Mars looks quite bright tonight. That's the planet that we can see the best right now. If you go outside right as the sun is setting, so by 10 o'clock it's already set, the planets Saturn and Jupiter are up. And if you wake up early or stay up late right before the sun comes up in the east, you can probably see Venus right now. It's in our morning sky. But the easiest, most convenient planet to see right now is our planet Mars in the south sky. Let's move on over to our eastern sky, because we're changing seasons, right? So we have, right now we're definitely in the fall, and we do have our fall constellations. I wasn't going to talk about those too much. I see Perseus here. There we go. Let me get rid of those. Okay, so there's Perseus, who's a fall time constellation. Here's our, there's Andromeda in the Great Square of Pegasus. We've talked a lot about these, in fact, on our last episode. And then the episode before that, we really talked a lot about our fall constellations, so I'm not going to talk too much about them. But we call them the fall constellations because here in the Northern Hemisphere, fall time is the best time to see these stars. So, and you can see they're really high in our sky. They're up all night. However, winter is coming. And our sky is showing us this. So by 10 o'clock tonight, which is what we have our sky set at, we have, turning the atmosphere off again, we have our constellation Orion, who is the great hunter in the sky and sort of the centerpiece of our wintertime sky. And there we go. And he looks, if you can imagine, here's his shield out in front of him. He has his arm and a club he's holding a club over his head. His belt is down here, his legs. The artwork does a good job at showing this too. Sometimes he's represented with a shield he's holding in front of him. Sometimes it's this lion pelt, which has to do with mythology, a Greek myth. But it looks like in any case, it always kind of looks like he's fighting or he's locked in battle. And he's locked in battle with Taurus the Bull. So Taurus is a transitional constellation. It's a fall time constellation, I think technically, but it starts to come up and it's right next to the wintertime sky as well. There's a lot going on in Taurus. I'm going to turn the artwork off so you can see the stars a little better. Aldebaran here is a bright red giant star in Taurus. The face of Taurus the Bull, makes a little V in the sky. Those stars are physically close together. They're called the Hyades or the Hyades. So with the exception of Aldebaran, all these stars right here in this region of the sky, they're physically close together. There's another star cluster, the perhaps more famous star cluster in Taurus, on the back of the bull here. This is the Pleiades. Sometimes called the Seven Sisters, sometimes called Subaru. So even our cars, actually there's a ton of examples of cars being named after or being influenced by astronomy in their names and logos. In fact, Subaru's logo looks very similar to this. I want to zoom in a bit because I think a very popular star, my favorite star, and I know probably Kurt's favorite star as well, is this star here called Merope. Merope in Harry Potter was the name of Tom Riddle's mother. So Lord Voldemort's mother was Merope Gaunt. And it's also the name of an adorable kitty that's sometimes featured on our shows. So lots to look at in our nighttime sky. In Orion itself, we have almost the whole Black family, not everyone, but many members of the Black family were named after stars, or even the constellation Orion. Orion Black was a character. So one of the more popular ones was, of course, Bellatrix. Bellatrix is the shoulder star of Orion, his left shoulder. Bellatrix means female warrior. Pretty cool. Let's stay up a little bit later. I'm going to move forward in time. Let me show you what time we're moving up to. So we're moving forward. We're about 11 o'clock. I'm going to keep going. I'm going to say till maybe 1 a.m., 2 a.m., something like that. If you like to stay up late, it's 2 a.m., you get a sort of a sneak preview of the wintertime sky. More of the wintertime sky is rising. It's not a super convenient time to see the winter sky because you have to stay up till 2 or 3 in the morning, but it's not as cold as it will be in a few months when these are front and center shortly after the sun sets. So yeah, you have to take your pick, I guess, if you want to see these. But rising over in our east, just below Orion, is Canis Major, the big dog. And the brightest star in the nighttime sky is the collar, or sometimes drawn as the nose of our dog, Sirius. As in Sirius Black, if you're a Harry Potter fan, was a major character in our shows. And if those Demetars or Demeters, I forget how to pronounce it, knew anything about astronomy, then they would know.
Dementors.
Dementors, thank you. Yes, Dementors. If Dementors knew anything about astronomy, then they would have been able to catch Sirius Black way quicker than they did in The Prisoner of Azkaban. So, J.K. Rowling was clearly inspired by the nighttime sky when she wrote and developed the characters in her show, or in her books. One character, everyone's favorite, not everyone, but most people's favorite, a lot of people's favorite, is our moon. Our moon tonight, it's near the constellation Cancer there. People sometimes ask me, well, why do other planets' moons have names? Like Jupiter's planets have really cool names like Io and Europa and things like that. So why doesn't our moon have a name? It does have a name. It's Luna, as in Luna Lovegood. So it looks like tonight, what do we have? Is this a waning gibbous still, or is this a
last quarter tonight?
Okay,
last week on Halloween was the full moon, so this week we've got a last quarter.
You're right. We're exactly a week after the full moon, which was on Halloween, our blue moon. I hope you guys went out to see that. That's pretty cool. So a week after the full moon, we have what's called a third quarter moon, last quarter moon. And that's what we have tonight. You won't be able to see it. It does not rise until very late in the evening, probably around 11, midnight, something like that is when it'll rise in the east. Okay, so those are just a few things that you can see in the sky and look forward to. We'll probably go into more depth on our wintertime sky as we get closer to winter and get into winter. It's a beautiful time to go look at the stars and be inspired, as many of the artists that we have come to enjoy have. Do we have any questions so far before I wrap up our star talk?
I don't see any in the comments right now. I would point out to our audience, though, how extremely rare this weather we are enjoying right now is for early November in northern Ohio. I think we've got one chance of rain in the next week. So if you get a chance to go out and look at the nighttime sky, please do.
Absolutely. I've been going for long walks every day just because it's so beautiful out there. And then at night as well, we have bright sunny days and then clear dark nights. What? That never happens in Youngstown. Go take advantage of it. Absolutely. Thank you, Kurt. Okay, guys, I think it's time for us to talk a little more about astronomy and pop culture.
All right. So Tiffany mentioned all the Harry Potter references. We talked about Contact. We talked about Mars, lots of movies with Mars. So I am going to try to share some slides, which could be interesting. No, that's not what I want to do. Hold on. I want to present. There we go. Okay. So I think that's it there, and I'm going to share screen. There we go. Okay. So first up, Tiffany mentioned the star Vega and the movie Contact. And what we're doing here really is we're talking about things movies got right, things movies got wrong. Well, the book Contact was actually written by Carl Sagan and is a very plausible way how we would probably interact if we discovered we weren't alone in the universe. Jodie Foster was a radio astronomer. By the way, radio astronomers never do this. They never have headphones up on their ears like this next to radio dishes. You look at radio waves the same way you look at visual light waves in radio astronomy. But hey, they wanted her to listen, so that was a trick of the movie that they didn't get right. But the basic plot is she's listening for signals from outer space, and this took place in the 90s. It's 26 light years to Vega. So what they got back was this signal, and it was actually a rebroadcast of the very first television signal sent from Earth with any kind of strength, which just so happened to be Adolf Hitler announcing the beginning of the 1933 Olympic Games. So it took 26 years to get out to Vega. They sent it back saying, "We heard you." And then the movie goes on from there. So little details like that are what are the hallmark of Contact, and they did a very good job getting the distances and things out there, and probably how we would react if confronted with an alien culture with that as well. Now, I don't know how to advance this. Oh, maybe down here. Oh, I
just want to reiterate this movie was actually lauded as a being very scientifically accurate, but the famous scene of Jodie Foster wearing the headphones, listening to the radio signals, people in the science community still kind of make fun of that because it's just so not what radio astronomers are about. Radio astronomy is radio waves are visible or are light waves. They're not visible light waves like that we can see, but they're treated as light waves.
Well, they would be visible light waves if your eye was as big as that dish that's behind Jodie Foster there.
Yes. So the human eye can't see them without help. But so it we use radio waves to transmit sound. So that's how we think about radio waves. But it's not at all what a radio astronomer does.
No. And this was filmed at the VLA, the Very Large Array in Alamogordo, New Mexico.
Yes.
What was fun was when the movie came out, I was actually hanging out with a bunch of amateur astronomers in West Virginia, and we were over at the other branch of NRAO at Green Bank, West Virginia, and they all went to see it as one group and were cheering whenever the NRAO logo came up in the movie. Always fun with that. But yeah, a lot of the scientific details in this movie they got correct.
Yeah.
But let's move on to other movies that got things right and got things wrong. Let's start with Star Trek. This is probably the granddaddy of all. And by the way, I should mention that I was, when my brother and sister were born, my dad was watching Moby Dick. And then when I was born, he was watching Star Trek, and now I'm an astronomer. So just one of those things, I guess. Kind of little foretaste there. But this came out in the late 60s, the original show by Gene Roddenberry. Actually, it's kind of like life imitating art in a lot of cases. One of the reasons we have here, you see James Kirk using a communicator on Star Trek. And if you notice, that looks very much like a device you might have in your pocket right now. As a matter of fact, a lot of the early engineers of cell phone technology, when they made the original flipped ones, were all Star Trek geeks, and they based it on what they saw in the original Star Trek series back in the 1960s, which is always fun too. Something else they got right, even back in the 60s, but also back with the Next Generation in the 90s as well, was what we're doing right now, and that is video chatting. They got that right as well. But not everything that the original series did was 100% accurate. Granted, our technology has gotten better, and we don't have those clunky disks to stick into things to transfer data. We have the cloud and the internet and things like that. But I want to get our students in on this as well, and we're going to talk a little bit about what things are like in outer space when you don't have an atmosphere. Yes.
Kurt, can you click on gallery view so people, our audience, can see all of us? Right now, they can only see who's speaking.
Okay. Oh, I see. I can do that while I share screen, right?
I think so.
Okay.
You can try it. I haven't done it myself, so.
Okay. Let me try it again. I'm going to share screen. And then I click on participants.
The view.
Oh, view?
I think so. Gallery.
More. Sorry, we're doing Zoom live here, and I'm having fun with this. You're a co-host, Tiffany. If you can see it, go ahead and get it.
Okay, let me see. Maybe I can just share, because I think it's under share settings. Yeah, so video conferencing is everyday life, especially this year. And it's just funny that it was so integral in Star Trek. Like when that moment in Next Generation, when Locutus pops up on the bridge, whoa, that was that was so intense. And especially like with the original series, in the 60s, this stuff was just as futuristic as space travel. Like the idea of holding a communicator in your hand or being able to put someone up on a screen and talk with them, that was just as futuristic as traveling to moons and planets. Okay, let me see if I can share my screen, and then
I see participants. I'm there.
Yeah.
Okay. I got it. I think. Show small. There we go. I got it.
Do you? Okay. Yeah. I don't know if we do or not.
I'm seeing it now. I'm covering up Jean-Luc Picard, which is a good thing. But okay, now I'm seeing all of your back screen.
Well, yeah, but I don't know that. I don't know that Facebook.
Okay, let me share. Now that you're all up, let me share it again from here.
Okay.
There we go.
You want to try sharing again?
Sure. Okay. Now I think we're all up there. Did that work?
I don't know.
Oh, no, it says video thumbnails minimized. Oh, well. Anyway, let's move on. Let's run through our slides, and students chime in when we get to your movies here as well.
I had something to add with the communicator thing.
Oh, please do.
Like with the video chatting and just like generally when astronauts, like in movies, not just Star Trek, but like any astronaut or space movies, when they're like talking to people on Earth or in other spaceships, one inaccuracy is that there's no delay, but in space, you're very, very far apart. And the fastest thing in the universe is light, and that's how we communicate. We send like radio waves and things to communicate with each other from long distances, but that can only travel as fast as the speed of light. So for example, just to give you like an idea of how that works, it takes light 8 minutes to travel to Earth from the sun. And in some of these movies, these characters are like several stars apart, like they're flying around like all different like planets and like throughout space, but they're shown communicating in real time, which wouldn't happen in real life.
Yeah, good point. By the way, Tiffany, I think now you have to have control of the presentation.
Okay.
I don't think I'm going to be able to control it. You'll have to advance. Okay. So next up, we have the movie The Martian. This was written by a gentleman named Andy Weir. Tiffany, why don't you tell us a little bit about his background, and then we'll get into the movie a bit. Because
yeah, so the author of The Martian, Andy Weir, he kind of became, I guess, a bit of a celebrity when the movie came out, at least in the nerd world, because he just spent so much time researching for his book, and it really was a labor of love writing that book. It was almost like his version of fandom for NASA. So he did not work for NASA. He was not an astronaut or even really a scientist. Most of his life he spent working as a computer programmer, but he loved NASA. He loved all things space. And he loved these sort of thought experiments of, okay, if we go to Mars, what is that going to look like? If we got stuck on Mars with the current NASA technology, how could we get off the planet? How could we survive? And that's what created this story, The Martian. It was kind of a thought experiment, which is where really good science fiction really starts.
And I have to say, it is actually one instance where the movie was almost as good as the book, which is saying something. They did a really good job with the book, with the movie, and a lot of the stuff in the movie that wasn't in the book was the behind-the-scenes stuff at NASA. There's this whole part where he's alone on Mars, and they just concentrate on Watney, who you see here as Matt Damon. And you don't know what's going on behind the scenes at NASA until about halfway through the book. Well, in the movie, they have that going through all the way, and all the politics, how it plays in, and all that kind of stuff. So they did a very good job with it. But here, the scene that we actually have up is interesting. Andy Weir actually laid out a map of where they landed this mission, and Mark Watney actually traveled and retrieved the Pathfinder mission that landed on Mars in 1997 so he could communicate with Earth. And he set it up to, here it was his first attempt at communicating with Earth, where the camera would point and they'd turn the camera to yes or no. And it was the first way he could communicate with Earth. But in this movie, they got the time delay right. There was a 20-minute time delay between the time he would set stuff up and then he would see the camera work. So he eventually they set up a system where he could talk using ASCII language, and he set up a way to do that. But he would set up a message and then go away for 20 minutes because it would take him that long. It would take him 40 minutes to get the signal back. So there's one they got right. Also, he was the fix-it man and a botanist. So one of the challenges he had was it was going to be almost a year until they could actually rescue him. So he had to figure out how he was going to eat. So let's move on to the next image there.
We're seeing some comments here.
Oh,
Matthew was saying that Artemis by Andy Weir is really good too.
yes, I
And
love that book as well. That's
Kurt
about,
keeps bugging me about watching it or reading it because I
yes,
haven't read it yet, but I'm so excited to. I just
that's about
if
a moon colony, and he did a
yeah.
very good job with that as well. And
So
he's
that
got
was his
more coming
second
out in the
book. The
spring.
Martian was his first was Andy Weir's first published book. Um, Artemis, it's kind of like a treasure I've been sort of holding because I enjoyed reading The Martian so much. I just want to like wait until I find a good time to read it. But I hear it's really good as well.
Yes, and he's got a new one coming out in the spring.
He does. Do you know anything about it?
No, I have it pre-ordered on Amazon, but I don't know anything about it yet.
Wonderful. Well, it'll probably have some good science in it.
Yeah,
Oh, one thing. Are we still talking about The Martian? Are
yeah.
you moving on to The Martian or?
Well, I was going to move on to the potatoes, but yeah, go ahead.
Okay, go to the potatoes.
You got to move the slides.
That's right. Technology. Jeez. There's the potatoes.
Yes. So it just so happened that they were going to have Thanksgiving on Mars, so they sent potatoes along, and he, being a botanist, figured out how he could grow 'em. I'm not going to go into those details. You'll have to watch the movie or read the book because, this is a family show.
But
So,
this, I mean, in general, could, like in theory, could happen. And in fact, um, it will have to happen. We will have to be able to, we have to learn how to grow food if we want to send people to Mars. It's going to be a really long mission. I think, what, like 1,000, not 1,000 days, but how long is the mission to Mars? 2.5 years?
I think it's 3 years.
Yeah,
It has to
something
be at
along that
least
line.
3 years.
Yeah.
And that's even
So
with a minimum on there, so a minimum time on Mars.
so right now, NASA is actually in the Atacama Desert, where we've talked a lot about ALMA and the radio observatory ALMA that's in the Atacama Desert in Chile. It's the driest desert in the world. It's very Martian. The climate there is about, especially if you get up in the mountains, is about as close to a Martian climate as you can get. And so NASA has been running experiments there with what we call analog astronauts. They're people who kind of try to simulate what astronauts. They're like product testers for astronauts. So they test new um, equipment and they practice growing food in a Martian climate. So things like that. This is absolutely a true real life scenario of what we could expect in going to Mars. One thing that he technically Andy Weir did get right in the book and in the movie. There was I won't go into too much because I hate spoilers, but there was a situation where he had to create water, and he did that with like a chemical process with taking two hydrogen atoms and an oxygen atom and putting them and like fusing them together, which is incredibly dangerous and can cause a huge explosion. So it's like really intense. That's not how you would want to get water. Not the easiest way to get water. And then since the book was released, shortly after the book was published, NASA discovered water on Mars in the dirt in Mars, very brackish, very salty water. And it's not like lakes of water on Mars or anything like that, but there is water in the soil that could be extracted if you were clever. And I think Mark Watney would have been clever enough to extract water on Mars. Elaine, or students,
Well,
did you
before
guys
we
have
get to that,
anything?
while you're talking about that, something else they're working on is a way to extract oxygen out of the thin Martian atmosphere. NASA's actually working on that right now, and I think they had a breakthrough recently.
Cool.
So, yes, on to Elaine in the next slide.
Is it on the next slide?
Yeah.
Gotcha. There it is. No,
Yeah.
this isn't it. Is this it?
Yeah, that's
Okay.
it. So, one thing that the Martian got wrong is the atmosphere of Mars. It's very thin. We do know there are dust storms on Mars, and they tried to portray this in the movie, but as you can see in the scene, it's super intense. There's a lot of debris flying around. When in reality, on Mars, the dust storms are more like a breeze because the atmosphere is so thin. There's just not enough molecules to get like a really, really strong wind on Mars. So that was inaccurate. And then one other thing about the Martian that's not accurate is the gravity. Mars is significantly smaller than Earth. So the gravity would not be nearly as strong as it is on Earth, but they're shown walking around just as normal as you would on Earth, whereas realistically, they would be just sort of floating around a little bit more. Their steps would be a lot more springy.
Yes, if you've ever seen pictures of the astronauts on the moon, it's a little bit more gravity than that, but a similar process. I will actually say another movie we didn't bring up, but Apollo 13 is actually based on what happened with the Apollo 13. I'll only go in to briefly say that everything that you saw in the movie Apollo 13 actually happened on the mission. They just compressed a lot of stuff for dramatic effect. But they filmed that in weightlessness to simulate what's going on. And I don't think they really could do that with the Martian, unfortunately.
Yeah, and in movies, sometimes they have to add, they don't have to, but they add elements that are perhaps either completely wrong with no scientific basis, or maybe stretch the science facts just for dramatic effect. So I think that's probably the case with those dust storms. It's way more dramatic to see them stuck in this like perilously thick, windy dust storm. When in reality, it might not look that way, but it would be that perilous still.
I will say that in the movie, one thing they did get right, he was going through a dust storm to get to the to where he's going to take off from Mars. And I don't know if they did this in the movie, but in the book, he didn't realize he was going into a dust storm, and it started to cover up his solar panels, so he started getting less and less energy. They did get that right.
Yeah, and the movie does do a pretty good job at staying with the book. I would say overall, of course, the book, The Martian, is more detailed and more scientifically accurate than the movie. But both are great. So however you enjoy your media, you should check it out if you haven't yet. What is this slide, guys?
We are moving on to our Arnold expert of Genie, and we are going to talk about another movie of Mars. That is Total Recall.
10 out of 10 on that accent. That's pretty good. Well, that was actually a really perfect transition to talk about the 80s sci-fi movie Total Recall, starring Arnold Schwarzenegger. We're talking about the atmosphere of Mars, and then we're also talking about elements that are used in movies that don't exist for dramatic effect. I can't really say a lot of good things about the science in Total Recall, though the movie is...
I will say it was a technological wonder when it came out. It was
one of
the best 80s SFX you're ever going to see. It looks cheesy now, but back then it was state of the art.
Right. And it was absolutely beautiful. I love the movie. I can say a lot of good things about the movie, but I can't say good things about the science. So there is barely any science, I will admit. What you see here in the photo is Arnold and Melina, and they're standing in front of this giant glacier here, right, which is underneath this huge, it's like a reactor that was built by aliens a long time ago on Mars, right? So we all know there are no aliens on Mars. And these are called the pyramid mines. So there's some sort of, I forget exactly where it's supposed to be, but there's some giant mountain on Mars, or a pyramid. And then the aliens built this giant reactor here, right? So we find out that this glacier is actually made of a fictitious element called, let's see if I can pronounce it correctly, turbinium, okay? And this reactor is supposed to, once it's engaged, it's supposed to melt this turbinium ice, right? And then it immediately, if you want to go to the next slide, you can. But when it's reacting, when it heats up the ice here, you see all of this this gas coming out of here. Where here's the pyramid where the pyramid mines are in. Basically, what it does is all of a sudden, in about a minute elapses in the movie where the pyramid mines, the reactor melts this turbinium ice and releases all of this oxygen. And all of a sudden, Mars has a breathable atmosphere, which I'm not going to tell you why that's important for the movie. You'll have to check that out yourself, right? But we have to think about this for a minute. I don't think that an entire planet would be able to have a breathable atmosphere in about a minute. Not to mention that turbinium doesn't actually exist. And they don't really give us any indication of what it's made of or why it's there. Their explanation is aliens, right? So if you want to go to the next slide, that's fine.
History Channel.
Yes, aliens, right? So here's what they depict the Martian landscape in the atmosphere after the reactor is engaged, right? Now, granted, this is about 30 seconds after everybody was close to death from lack of oxygen. So I guess my only comment about Total Recall is what they did wrong about giving Mars a breathable atmosphere. I don't think that the way that they have decided is actually ever going to happen. But it's an interesting science fiction movie about Mars, and it's very entertaining. And if you like 80s cheesy action sci-fi movies like I do, this is a good time. I do recommend you watching this one before the new one. Just saying. But yes. I don't really think they got a lot of things right about Mars, as their original atmosphere and the landscape was incredibly red. It's probably more orange and rust-colored brown. And the sky was blood red. So the atmosphere doesn't actually look like that on Mars. And there's no turbinium on Mars. Fun fact.
Yeah. But terraforming has been, a topic that's really common in sci-fi stories. But with the current technology we have right now, terraforming on Mars just isn't possible. It could be possible in the future, and this idea of modifying the atmosphere to create life safe conditions for humans. That's something that we've thought about, but it's not possible with the technology we have yet.
I will point out that back when Mars, in its early years, the reason we see all these canyons and water rivulets and stuff there was once a much thicker atmosphere on Mars, but because it is so small, it's only about half the size of Earth, and it has so little gravity. Unlike the Earth, which was able to hang on, most of its atmosphere escaped off into space, and at that time the water all either evaporated or went underground. So that's why we know water is still there. The new missions are finding that, but most of the atmosphere has gone into space, and even with turbinium, I think they'd have that problem in this movie too.
I completely agree. I don't think we could give an entire breathable atmosphere in a minute. I feel like that, even if we did decide to do that and we had the technology and capability to do that, which is very far-fetched, it happens very quickly.
All right.
Charles has a great question about Mars before we move off this planet. How do we know, or do we know how different the soil is on Mars than compared to here on Earth?
That's actually one interesting thing in the movie The Martian. They talk about, because the atmosphere is so thin, the sun has irradiated the atmosphere and there is no living bacteria whatsoever. Even here on Earth, in the Atacama Desert, in Antarctica, any bit of ground you turn over, it's absolutely chock full of bacteria everywhere you go on Earth. And it's not there. One of the things Mark Watney has to do in the movie to grow the potatoes is introduce organic material to feed the potatoes in the soil, which is a rather gross thing that I won't go into right now. You'll have to watch the movie. So,
spoilers. We'll just say that. Spoiler
alert. So anyway, that's actually one thing The Martian got right.
Yes, and we want to bring soil samples back from Mars, right? I'm blanking on exactly what mission that is.
Perseverance.
Perseverance. Okay. Yeah.
Will reach Mars on February 21st or 2/21/21, which is really cool. And it's actually like Curiosity, except it is actually going to collect samples, and then a future mission that's going to be a joint mission between NASA and the European Space Agency will bring samples from Perseverance back to Earth.
So we'll know a lot more about what we would be able to answer Charles's question in a lot more detail after that. That's
Yeah.
exciting.
Stand by for about 2030, unfortunately, Charles.
Yeah.
Okay, we'll run briefly through some other ones. This is from the movie The Passenger, which got some things right and some things wrong. So Eleni can tell you a little bit about that.
Yeah. So yeah, this is from the movie Passengers with Jennifer Lawrence. So this is the ship that they are in, that the astronauts are in throughout the movie. I haven't actually seen the movie, so I may be getting some of this like not quite exact.
Well, I can give you a brief synopsis. It's a mission, a colony ship, so everybody's in hypersleep, except one guy gets awake, and there's some sort of malfunction with the ship, which is why the ship woke him up.
Wait, I totally did see this movie. I didn't even make that connection. I saw it when it first came out. I remember that now.
Okay, there you go.
I just didn't remember this part that I'm talking about. So in the ship, they have Earth-like gravity. And a lot of movies, as you've already seen, get this wrong. But they had a pretty good idea of how this works. There were some things that were still a little bit incorrect, but basically you see this giant ship here with like these arms coming off of it. The whole thing is spinning, and the people are all the way out in the edges of the ship, and as it spins, they're pushed out to the edges, and that's what creates the gravity. So the people are actually walking in those big long pieces you see on the outside. So that all makes sense. That's how we would simulate gravity if we ever had the technology to make a ship this big and we needed to simulate gravity in space. This is probably how we would do it. But there are some things wrong with it. Like at one point, the ship just magically stopped spinning. Even if we were somehow able to stop the force that was causing the ship to spin, it would, even if we stopped imposing that force on it, it would keep spinning because it's in space. There's nothing interacting with it. It would have to hit something or collide with something for it to stop. So at one point in the movie, it does just stop. And
for every action, there's an equal and opposite reaction.
It's the other one. Something that's in motion will stay in
an
motion
object that is in motion
acted upon by an outside source. Yeah, force. So here on Earth, when you roll a ball, it does eventually stop because of friction, but there is no friction in space. So
yeah, exactly. So something else would have to act on it.
I should point out that going back to The Martian, the ship that gets them from Earth to Mars and back never goes down to the surface, but it has a section like that too. It's 0G and a lot, but it's got a center drum that turns where they do their exercise and stuff so they can simulate gravity and don't have bone atrophy.
Right. So another scene from this movie that's also kind of accurate but kind of not accurate is there's a scene where Jennifer Lawrence's character is in a swimming pool. And it's at this point, again, the ship stops turning, so the gravity shuts off. And they even show the water like sloshing forward as the ship stops spinning, which would happen. The water would have inertia, like we just said, in motion, stays in motion, and it would sort of slosh. And then the water would actually float in space and rise up out of the pool, and it would stay in a ball shape because of surface tension of the water. So eventually in this scene, all of the water sort of comes together, and the surface tension keeps it in a ball, and it's just floating. And Jennifer Lawrence's character is trapped in this ball of water, and she's trying to swim to escape it, but she has no leverage because, again, she's in space. There's no gravity, so the water's kind of moving with her. And that's a really accurate portrayal of what would actually happen in this scenario.
I highly recommend, if you're interested in how normal everyday objects are affected in space, There's some really great videos of astronauts on the International Space Station showing the effects of space and zero gravity, and like candlelight, just a candle flame. You think it looks weird. It's really cool. So anyway, there's all kinds of cool YouTube videos about that sort of thing.
Right.
Now, I don't know what slide we have up next. What's our next slide?
I don't know either. Oh yeah, this one.
Oh, okay. Well, we've talked a little bit about this with the Martian, but we also wanted to talk about, and you can't see the phone because of us. Oh, well. We wanted to talk a little bit about how NASA has impacted our everyday life as well. So it's not only pop culture, but it is what NASA has provided to us. There's tons, and we could do a whole show just on that. But this is just a really good example. This room you see here is a computer from the 1960s. And when they were going to the moon, they had to figure out how to fit this room into the lunar module to land on the moon. And because of that, the thing you have in your hand right now, this little guy right here, is because of NASA going to the moon. Basically, they had to figure out how to miniaturize everything, and the laptop we're broadcasting this on, the phone in your hand, your tablet, those are all direct results of the space race. As a matter of fact, this cell phone has more power in its computer than the computers on the command module and lunar module combined back in the late 60s, early 70s.
And so this is people sometimes argue about whether or not we should be investing taxpayer dollars into exploring space. And I think it is a really valid argument to say that the technology we develop in pushing ourselves out into space really does benefit people from back home, back here on Earth. So you can think, anti-scratch glasses, like scratch-resistant glass for your glasses, that was developed as a technology for NASA. The
Freeze
cameras
drying came from going to space to store
the
food.
what?
Freeze drying food.
Oh, freeze drying. Yeah, the ingredients in formula, like in baby formula, that there's an ingredient in baby formula that was developed through NASA in its process of trying to develop food for astronauts in space. And the little tiny cameras, like the cameras we have on our phones, all kinds of stuff that you wouldn't think about. So, thank you, NASA. And
NASA actually has, you can go to their website. They actually have a really good, just look up NASA technology in everyday life. There's tons of great articles about it. You can even Google it and find it.
Yeah, and sometimes these really great sci-fi classics and sometimes our media influences our science. So it's and then the science inspires the media, and then it's sort of the circle. So it's really interesting to see that that loop.
And there's another connection NASA has to pop culture as well. And I'm going to turn you over to Eleni to talk a little bit about that.
Yeah, so this is the Hubble Space Telescope. Ever since the Hubble Space Telescope was launched in 1990, it has had a huge influence on pop culture. Before that, we really didn't have super good pictures of astronomical objects out in space. The Hubble has taken a lot of famous images. Pretty much any picture you see of another galaxy or a nebula or something probably came from the Hubble Space Telescope. And here, these are just a few popular ones that you might recognize. The first one is from it's an album cover from the band Pearl Jam. That is the Hourglass Nebula. And obviously that picture is edited a little bit for the album cover, but that is a picture taken by the Hubble. And a lot of Hubble images are used. They influence art, music, movies, and even fashion. A recent trend is like galaxy print clothing. So my backpack has like a pretty like nebula with some stars in the background on it, and I have I have clothing items that are what they call galaxy prints. And that wasn't really a thing before the Hubble Space Telescope provided these pictures that inspired all of this art and fashion and music and stuff like that.
Hubble's
Now-
amazing.
Yeah. Now there's tons more we could talk about, like the way, Star Trek and Star Wars got flying through space and fights in space wrong and stuff like that. But this
Yeah.
is such a depth topic. There's always stuff to talk about. Please look at the comments afterwards. Oh yes,
We
have
do have a
Nishan.
couple more things
Sorry,
to talk
Nishan,
about.
I forgot about that. Yeah.
Yeah, we did.
This is
So
from the movie Interstellar. We are running a bit long, so we'll
Yeah,
talk
we
briefly
got-
about the movie Interstellar. It got some things right and some things wrong with Nishan, and then we'll wrap up. Sorry.
So regarding the movies that got the science factor right in sci-fi movies, Interstellar is definitely on the top list of one of the movies that got it right. I mean, the movie has the fiction part in it, but most of the science on it is pretty much accurate. And this is one of those scenes. When I first saw this scenes, I was a bit confused in the beginning, but I eventually got it. So what happens in it is that the scientists, they go to a planet which is revolving around a black hole, and they go there because they find data that the planet might be suitable for living. And when they go there, it's all covered in water, and they land their spaceship, and then they send the rovers to get the data points. And the main astronaut, he looks fun, and he sees these big mountains in front of him. And then eventually he realizes that those are not mountains, instead those are waters. And they are so high, they are so big. And the reason why these are so big is because of the gravity of the black hole. Just like how moon causes tides on Earth's surface, the black hole is causing tides on this planet. Just that the gravity is so big that the tide is also so big. And it was pretty cool that they got this right. I was pretty fascinated by it.
Next slide there, Tiffany.
And yeah, this is another part of the movie that they got right. And this scene talks about time dilation concept, which is a real thing. And I think it has also been proven. So what happens is that gravity is a very mysterious thing, and it actually affects time. So if you are in a planet or in a region which is very high, where the gravity is very strong, it actually dilates time. So for a person who is not in the gravitational region, he might experience 1 year, where the person who is in the region where the gravity is high, it might just experience 1 second. And the person who is not in those regions might be way older when the person who went in that region and came back. Like the age difference will be pretty much high within those people. And Einstein actually came up with this idea, and they even showed this idea in the movie. It was pretty interesting.
It's sort of
Also a very
mind-boggling.
popular topic in all sorts of science fiction. Isaac Asimov used that a lot too.
Yeah,
Wind paradox and
it's
stuff.
wild. One of my favorite short stories, I believe it was Ursula K. Le Guin. One of her short stories involves this too. And but the wild part about it is that it is scientifically accurate. Einstein's theory of relativity says, I think it's the general relativity, it says that the time dilation is real if gravity can affect time. And so when you're experiencing these extreme gravitational forces when you're near a black hole, not near enough to get caught in it, but even just close enough to it, it can affect time. What? Crazy.
All right, so I guess you can stop sharing your screen there, Tiffany. And
Oh yeah, we don't have time to talk about Gattaca, although it's a really great movie too. I
Yeah.
highly recommend watching it.
NASA actually calls it the most plausible of all science fiction movies, but
It awarded Gattaca the most plausible movie of 1997 and beat out Contact that year. So, because the both movies came out the same year. Highly recommend watching it. It's one of my favorites.
Gotcha.
But yeah, we didn't even talk about laser beams in space or the fact that in Star Wars, Tatooine was a planet orbiting 2 stars, and we have now since then actually discovered an exoplanet orbiting 2 stars. So sometimes fiction can become fact. So anyway, there's so much to discuss. We really can't even do it in one episode. But
And if
that's
you
just a
have
few.
anything you want to see that you saw a science fiction movie is this accurate, please share in the comments of the video. We'll be happy to respond to that. We will be posting the recording of this on YouTube. You can also leave comments there as well, and we'll be happy to respond to those as well.
Absolutely. We're all nerds here, so we'd be happy to continue the discussion in the comments below. Love to hear more examples of your favorite media, TV, movies, whatever. And where do they get the science right? Where did they get it wrong? It's usually somewhere in between, right?
Okay, well, I will tell you that next time we will not have Tiffany with us on our Keep Looking Up. That's because you probably can't see on here. She is just about to have her second boy.
Yeah.
And, so she's about to head off on maternity leave on us. So I'll be hosting next time, hopefully without the glitches this time. And in that, we will be having Eleni talk about dark matter. And hopefully, we're still working on this. Our planetarium director, Dr. Patrick Durrell, will be back to talk about galaxy motion. So hopefully we'll be able to work that out for you. That'll be taking place on November 21st. So we hope to see you back for that. And like I said, leave comments. We have lots of videos that we post on Facebook and YouTube. You can subscribe to our newsletter, which is tagged at the top of the comments here on Facebook to get regular updates on those videos coming out. And until next time, we hope you will keep looking up and take advantage of this nice weather, will you? You're not going to get weather like this for another 3 or 4 months. So go out and look at the stars. And with that, we'll say good night, everybody.